Chapter 12, Section 7, the Law of Sines. And it's one of the California State Trig Standards, it's number 13, to know the law of sines and apply those to solving problems. So our objective today is to know the law of sines to find various sides and angles. The law of sines actually is proportion, and it says if you know the sine of angle A, you put that over the length of side A, and that would be equal to the sine of angle B over the side B. But it's also possible we could do the sine of angle A over side A equals the sine of angle C over side C, or the third combination, the sine of angle B over side B equals the sine of angle C over side C. So usually when we write the formula, we write it in this format, and it's any two out of the three fractions we use. And when we apply the law of sines, first of all, it's when we do not have a right triangle. That's when we want to apply the law of sines. And depending on which ones you have or don't have, you would need to know 3 out of any 4 pieces of information. In other words, you would need to know both angles and maybe one side to find the missing side. Or maybe you know both sides and one of the angles to find the other angle, depending on what the particular situation and the problem is consisting of. So let's look at our first problem. We have a triangle ABC. We know it's not a right triangle if we fill in all the information that we have about it. Side A is 4.56, and remember that's opposite angle A, which they're telling us is 43 degrees. They want us to find side C, and side C is opposite angle C, which is 57 degrees. We don't know side B, we don't know angle B. But that's all right, because we're going to take the sine of angle A over side A equals the sine of angle C over side C. And in this case, angle A is 43 degrees, side A is 4.56, angle C is 57 degrees, and side C is what we're looking for. Let's do looking up the sines first. So we'll type in 43 degrees, hit the sine button, round that to 4 decimal places, 0.6820. Then type in 57, hit the sine button, round that to 4 places, that's 0.8387. And we have a proportion. When we do that, we know the product of the extremes equals the product of the means. Let's do our multiplication. 4.56 times 0.8387 is 3.8245. And if we divide both sides by 0.6820, we will find out what C is. So let's do that. And C, side C, is approximately 5.6078. And for triangles, we usually take the sides and round them to the nearest tenth. So C is approximately 5.6. And so there's the situation where we use the law of sines. We knew what angle C was, and we needed to find out what side C is. All right, let's look at another example. In this particular case, we've got triangle ABC, which is not a right triangle. We know that side A, which is 3, is opposite angle A. Side B, which is 7, is opposite angle B, which they told us is 150 degrees. And they want us to find angle A. So again, we know 3 out of the 4 pieces of information, and you always need to have at least an angle and the side opposite you know, and then you can either find the side or the angle that are opposite each other. So let's set this up as the sine of angle A, which we don't know, over side A, which is 3, is the sine of angle B, which is 150, over side B, which is 7. Let's look up the sine of 150 degrees, type in 150, hit sine, round that off to the nearest, well actually 4 places, but it comes out exactly 1/2. So that sine in quadrant 2 is positive, and that's 1/2. Right, we've got a proportion, so the product of the extremes equals the product of the means. Divide both sides by 7. So 3 times 0.5 divided by 7 is 0.2143. Again, we have a situation where we don't know the angle. There was some mystery angle. We typed in the sine button, it got 0.2143. So we want to take the inverse sine of both sides of this equation. That'll get the angle A by itself. And on our calculators, again, if we type in 0.2143, hit that inverse or second function button, then hit the sine button, we'll get 12.3745 decimal degrees. And if we round that to the nearest tenth of a degree, angle A is 12.4 decimal degrees. All right, let's look at a real-life situation expressed in sentences. Here we have a 123-foot support wire for a transmitting tower. Makes an angle of 61 degrees with the ground. So here's our 123-foot wire. Here's our angle of 61 degrees that it makes with the ground. And this wire is to be replaced by a new wire. It's going to be longer because its angle with the ground is 46 degrees. What we need to know is how long is that. Now you could think of this as two right triangles, or we could actually think of this as one triangle that's not a right triangle and use the law of sines. So first we need to find this angle ACB. We know that ACD is a straight line. That's a straight angle, which is 180. We're going to subtract BCD, 61, from it to find out that this angle ACB is 119. We're looking for the length of this wire, which is x. And if we look at this triangle now, we know an angle and the side opposite. We know another angle, and we're looking for the side opposite that. We know 3 out of the 4 things, and it's time to use the law of sines. So the sine of angle C over side C, which we're calling x here, is the sine of 119 over x. That equals the sine of angle A over side A, which is the sine of 46 degrees over side A, which is 123. Let's look up the sines. 119 degrees, press the sine button, round that to 4 places, 0.8746. Type in 46 degrees, hit the sine button, round it to 4 places, 0.7193. Again, we have a proportion, so the product of the extremes equals the product of the means. To simplify that, let's divide everything by 0.7193. That'll get the variable x by itself. So 123 times 0.8746 divided by 0.7193 is 149.5562. And since it's a side of a triangle, we really can round it off to the nearest tenth. So this wire would need to be 149.6, and this problem is feet. 149.6 feet. And that's today's lesson on the law of sines.